Hello everyone, and welcome to today's lecture. I hope you're all keeping safe. In today's online lecture, I want to cover section 3.3 from the book, which is called the chain rule. This section is relatively short compared to some of the other sections in the textbook, but it is still actually very, very important. Now, chapter 3 is all about rules for derivatives, and as the title of the section probably suggests to you, the rule that we're covering this time is what is called the chain rule. Now, the chain rule is the rule for derivatives of function compositions. So if you struggled a bit on the sections of the textbook and of this course that related to function composition, it's going to be very important that you go back over that and be as solid as you can on that material if you want to be able to be successful with the chain rule and with any problems that will require the chain rule. And that's going to be a lot of the problems in this class. So what does the chain rule tell us? Well, the chain rule tells us that if we have a function that goes from x to y, and then another function that goes from y to z, well, we might be interested in sort of their composition, which is the overarching function that goes from x straight to z. And the chain rule simply states that if we look for dz dx, which is going to be the derivative of this arrow here, it turns out that this is simply equal to dz dy multiplied by dy dx. Which are the derivatives of these two arrows here. This dz dy comes from the green arrow. The dy dx comes from the blue arrow. And if you multiply those two together, we get the derivative of the red arrow. In some sense, this rule simply states that the dy down here and the dy up here can cancel out. So this is how the chain rule works with what we call that Leibniz notation. Now, oftentimes, students prefer to use our more standard Newton notation, the one with the f primes and g primes. And in practice with the chain rule, it's often a lot more convenient to work with that type of notation as well. And if we reinterpret the chain rule that I just wrote up here, using the standard Newton notation, we get the following formula for chain rule, which is the one that I want you guys to remember. Chain rule states that the derivative of f of g of x is equal to g prime of x times f prime of g of x. This version, this formula, is the one that you guys will use the most often. So the question now becomes, how do we use this chain rule to actually calculate derivatives? And as usual, I'm going to prefer a sort of multi-step process. And step one is going to be to identify an inside and an outside function. Basically, step one is going to be those reverse engineering. problems from function composition that we saw in chapter 1. Once you've done that, step 2 is to write out, and I don't just mean on your scratch paper, I mean on your actual work that you actually turn in. I want to see f of x equals. I want to see f prime of x equals. I want to see g of x equals. And I want to see g prime of x equals. And obviously, for these two, you'll have to calculate these derivatives. Now, once you've done these first two steps, step 3 becomes to write out the formula for chain rule. So by that I mean literally just write this formula out on the page, just this formula up here in orange. And step 4 is just to plug in. So as usual, let's tackle some examples. And the first one I want to go over is this one, where we have a function h of x, which is equal to ln of 3x squared. And we want to find its derivative. So step 1 is to identify the inside and the outside function. In other words, we want to write h of x as equal to f of g of x. And we need to figure out what f of x is going to be and what g of x is going to be. Now, a good plan for this, usually, is to look for anything that's inside the parentheses. And here we see that inside the parentheses, we have this 3x squared. And that will usually line up with your inside function, which in this case is going to be g of x. Once you've done that, you just look for whatever is on the outside of that. And we see that on the outside we have ln. So those are going to be the inside and outside functions that we are going to use. We will use f of x equals ln of x. And we will use g of x is equal to 3x squared. Now, as I mentioned over here in step 2, I don't only want you to write this out, which you absolutely should. You need to write out both of these functions. But you also need to calculate these derivatives. You need to find the derivative of f and the derivative of g, and you need to write them out. So let's do that now. We need to write out f prime of x. F prime of x is the derivative of ln of x. And we saw from the log rule in class the other day that this derivative is going to be equal to 1 over x. And we also need to write out g prime of x, which is equal to the derivative of 3x squared. And by now you should be able to see that this derivative is going to be equal to 6x. And if you can't see this, if this isn't obvious to you, then you need to go back and review the rules from section 3.1, the power rule, and the scalar multiple rule. Okay, now we move on to step 3, which is as simple as just rewriting out on the page this formula here. And you should also mention that you are using the chain rule. So we just write out that the chain rule states that the derivative of f of g of x is equal to g prime of x times f prime of g of x. Okay, finally we get to the last step, step 4, where we plug in. And what are we plugging in? Well, we're plugging in these values that we wrote out in step 2. So we see, for example, that we have out here this g of x, or rather this g prime of x, and this needs to be plugged in out here. So we're going to get, this is equal to 6x. Now mind the parentheses here, they are important. And this comes from our g prime. And this is going to be multiplied by f prime of g of x, which we said up here is 3x squared. Now finally we need to plug this into f prime of x. And we saw that if we look at f prime as being f prime of blank, it's 1 over blank. In this case, we will be filling in the blank with 3x squared here. So this is going to be equal to 6x times 1 over 3x squared. Now again, if you want to, you can simplify this further. If I do not ask you to simplify, you are totally okay to leave your answer in this form right here. But of course, if you do simplify this, which is possible, you would get, I believe, 2 divided by x. And we are done with this problem. Let's do another example. So this time let's go over the function f of x is equal to 1 over the square root of the natural log of x. Now for problems like these, as usual, and as I've mentioned before in our previous lectures, the first thing that you want to do is rewrite any roots, any powers in the denominator, anything like that, as just whatever is inside them raised to a power. So we'll see that, in fact, this is just equal to ln of x raised to the power negative 1/2. So now we need to identify the inside and the outside function. And we see that inside we have this natural log of x, and outside is this power negative 1/2. So that was step 1, identify in and out. So step 2, let's actually write those out on the page. And we see that this time we already have a function named f of x, so we'll have to use different names here. Let's write our outside function as g, and our inside function as h. And we see that h of x is going to be ln of x, and g of x is going to be x to the negative 1/2. Now, as usual, we also need to find the derivatives of these guys and write them out on the page. So we need g prime of x. This is going to be a power rule. We are going to end up with negative 1/2 in front times x to the negative 1/2 minus 1. And then h prime of x is just going to be equal to 1 over x. Okay, we now move on to step 3, which is going to be the same thing. We're just going to write out that this is the chain rule. And in this case, again, we're going to be reusing this same rule here, but instead of f and g, we have g and h. So this time it will be the derivative of g of h of x is equal to the derivative of the inside, which is h of x, or h prime of x, I should say, times the derivative of the outside, so we have g prime, but where you plug in just the original inside function h of x. So all that's left to do now is to plug in. So this is going to be step 4, plug in. And we are going to get, first things first is the derivative of the inside function, which has to come here. And we see that that's going to be h prime of x equals 1 over x. And again, mind the parentheses, so we're going to have a 1 over x here. And just to keep up the color coding, we have that. And this is multiplied by g prime of h of x. So we're plugging h of x into g, and we see that h of x is ln of x, which we've color-coded in green. Now, what's g prime? Well, we see that g prime of blank is equal to negative 1/2 times blank to the power negative 1/2 minus 1. So our 1 over x stays out in front, and then this is going to be times negative 1/2 times, here we will have ln of x to the power negative 1/2 minus 1. And once again, if I don't ask you to simplify this, you can just leave this as is.